And here is number 9. So, tickets for a concert went on sale noon. The rate of tickets between 0 and 9 is the rate here. So, A. How many tickets were sold by 3 p.m.? So, remember that this is a rate of ticket sales per hour. So to get the number of ticket sales, we integrate from 0 to 3 of R of t dt. You can do this on your calculator, so we're not going to go through the ins and outs of it. So that is 972.84. So you can round that to 973, because remember, this is a rate. It's not an amount of tickets, it's a rate, and so we can integrate directly to get number of tickets. B. Determine the time of day at which the rate of ticket sales is the smallest. Again, remember, this is the rate. So we're maximizing or minimizing the rate. So don't be fooled by it saying the rate and thinking, oh, this is the derivative of something else, but this is the function that we're looking at. So we need to do r prime of t. Then r prime of t is going to be negative 550 over 2 e to the negative t over 2. Now what we're going to do that, we are going to set that equal to 0. So now, let's see, as you can see here, this is never going to go to 0. It just won't because it's an exponential. So because we're doing the maximum or minimum global, what you do is you test the endpoints and the critical points. There are no critical points, so we're going to test the endpoints 0 and 9. So at 0, there are 0 ticket sales per hour. At 9, there's 54.99. So the maximum, or is it the minimum? Oh, smallest. So it's going to be this one. Again, remember the initial function that you get is a rate. You can think of this like velocity. So then, just in the same way that if they said, here's the velocity, what's the change in position? Now find the minimum velocity. Here's the rate of ticket sales, integrated to get number of ticket sales, do the derivative to get the minimum rate. C, determine the average rate at which ticket sales are being sold over the 9-hour period. Now remember, that is 1 over b minus a times integral from a to b of f of x dx. In this case, it's r of t. So then what we do, sorry, b minus a, not b times a. So b minus a, that is 9 minus 0, integral from 0 to 9 of this function, r of t dt. Again, you can do this on your calculator, so no reason to do it by hand. Just don't do it by hand. Do it on your calculator. So that's 229.51, or approximately 230. That is the average rate. So remember, average of a function is the integral divided by the interval in which it is happening. D. Based on the context of the problem, interpret the meaning of r of 9 minus r of 0 over 9 minus 0. Well, that is just y2 minus y1 over x2 minus x1, which is the average rate of change of a function between there and there. This is what you did before you knew how to do calculus. Now E. How many tickets were sold at 4:30 p.m.? You're going to think that this is going to be really hard, but it's not. They say how many tickets were being sold per hour. The key here is sold per hour. They're asking for a rate of ticket sales. this function here gives you a rate of ticket sales. So literally all you're doing is R of 4.5, which equals 261. And there you go. This is not a hard problem, but you're going to have to do it a bunch of times. So that is number 9.